no matter which kind of fuel we use, we will have to burn less. We will have to use less fuel for the same service, for carrying the same number of passengers on the same distance. So, whether it's kerosene, whether it's SAF, whether it's hydrogen, we need to use less of them. So the energy efficiency is really something we are sure that it is going to deliver a result.
Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. I'm your host, Shashank Nigam, the CEO of Simplifying. Every Thursday, I have important conversations with top aviation executives, technology entrepreneurs, and policymakers helping aviation take climate action. Conversations that help separate the signal from the noise. Whether you are a frequent flyer or an airline executive, if you care about sustainability or simply love traveling, welcome aboard. My guest today is Valérie Guénon. Valérie is the VP of Products and Environmental Policy at Safran, a major engine manufacturer and propulsion innovator. Safran is leading a lot of the technological developments to reduce fuel burn and also look at future fuels and energy carriers for aviation. Valérie has spent many years of her life working at Safran, and she knows the technology in and out. It has been a pleasure speaking to her about what is the future of engine technology and how a large engine manufacturer like Safran can help make aviation greener. Valérie, it's great to be speaking with you. Finally, great to have you on the show. It's always good to get some technical expertise going to understand what is making aviation sustainable. You have been with Safran for a very long time. Can you tell us what your current role is at Safran and how you got here?
Yes, I've been with Safran for 36 years now, and I was lucky because Safran is a big group where you can do a lot of very different things. So I did have, I would say, a career, but with several jobs and in different entities of the group. And I started I would say, in a very classic way as a mechanical engineer in a design office. Designing aircraft engine parts.
And what has that led to now?
Today, I'm in charge of the environment policies for products. So environment and climate policies for products for Safran aircraft engines. And I represent the Safran Group towards institutions that make laws, regulations about aviation and the environment.
Fantastic. Now, for everyone to understand, how do you distinguish between environmental sustainability versus engine efficiency? Isn't a lower fuel burn equal to a more sustainable engine, or are they two different things?
Yes, well, definitely. The good news is that for decades, we have worked on the engine efficiency for economic reasons, because to provide to our customers more efficient engines, so less costly to operate. And the good news is that it has gone in the same direction as reducing the CO2 emissions per passenger kilometer. So definitely the environmental impact of an engine is linked to its CO2 and climate impact, but it's not only that, because engines also make a lot of noise, and so noise around the airports is also a question of health, and it's considered as an environmental. It is an environmental impact. They also emit, all those emissions. The emissions of an aircraft, they come from the engine. So we also emit polluting emissions that make people sick or could make people sick, like we also have in towns with cars. So we also emit so oxides of nitrogen, particulate matter, carbon monoxide, and so on. So that's what we call the local pollution. And then we also have an impact in during the cycle, the life cycle of the engine during its manufacturing, its maintenance, the full cycle has also an impact of, I would say, second order of magnitude compared to the first three.
What is the difference? What percentage of the emissions are the life cycle impact, the manufacturing and the disposal versus the actual running of the engine?
Well, if I speak about CO2 only, let me answer your question about CO2 only. Over its life, an engine emits CO2. More than 95% is due of these CO2 emissions is due to the operating of the aircraft, the use of the aircraft of the engine. So when the engine does what it is designed for, which is powering the aircraft. So 95% during the life of the aircraft.
Right. Very good to know this. Now, let's talk about one of the marquee programs that Safran has launched in partnership with GE, the RISE engine program, which I'm sure you have been a part of. Can you tell us a bit about the RISE program, what it aims to achieve, and how far you've got?
Yes. Yes, thank you for raising. It's a very important program for us, for our future. It is indeed a program that we have launched together with our long-time partner, General Electric. We are, we have a joint venture called CFM International, and we are 50-50 partners, Safran Aircraft Engines and General Electric. And we have successfully made the CFM 56, which is now a previous generation engine. We have made the LEAP, which is the current state-of-the-art engine, and we are preparing together a future engine. And to prepare this future program, so we have this RISE. RISE stands for Revolutionary Innovation for Sustainable Engines. And it is not just an engine, actually it's a technology innovation program. So it's a set of technology demonstrations. It covers a set of solutions, so with a set of technology bricks, and it includes several engine architecture and demonstrators. So usually when we speak about RISE, and the big picture is one of the architecture, which is called the open fan. So the open fan is the architecture that has the most potential for reducing CO2. So I can tell you why the open fan. So if you look at it, it looks like, it's an engine, and the fan, what we call the fan on an engine, is the big row of blades, which is in front. So it's the only part of the engine, of the turbo machinery, that we can see from outside. And so the open fan is basically an engine where you have removed the nacelle, the casing, and you see the fan, and it is big. It's very big. So why is this shape? Why is this architecture? On the engines, there is an important parameter of the energy efficiency, which is called the propulsive efficiency. So the propulsive efficiency depends on another parameter, which is called the bypass ratio. And the bypass ratio represents the share, the proportion of air that directly creates the thrust compared to the air that goes into the core of the engine. So basically, the more air goes through the fan, with an equal core size, the higher the propulsive efficiency. So the less fuel burn, basically.
When you say propulsive efficiency, that's basically the ratio. Lesser the fuel burn, the bigger the input. Is that right?
It is one parameter of the overall efficiency of the engine. We usually speak about the propulsive efficiency and the thermal efficiency. So these are the two efficiency parameters that we combine that make, in the end, the efficiency of the engine. And the propulsive efficiency parameter really directly depends on this architecture and on the bypass ratio. So it's the reason why engines, if you look at engines that date back from the 50s or the 60s, they were much smaller. It's also, if you look at a military engine, it has a very different size. It's much more narrow and long. And today's commercial aircraft, commercial engines, they have a very big diameter. Basically, it's because they are more efficient.
Well, I feel like I'm sitting in a aerodynamics class in the university. It feels so good listening to this. When we were doing research for this interview, we learned that Safran had dedicated 88% of self-funded research and technology spent to improving environmental performance. That is significant. What are some of the most promising areas of research, and how do you actually decide where to focus your efforts when it comes to research?
Yes, you're right. So 88% of the research, of self-funded research to improving environmental performance, so improving our climate impact, decreasing our CO2, improving the noise, the acoustics, improving as I said, the effect on air pollution and so on. Yes, it's significant. We've always done it. We've been successful at it because we have actually improved very much. If you compare, for example, the LEAP engine to its predecessor, the CFM 56, the LEAP engine has 15%, it consumes 15% less fuel for the same service. So for the same number of passengers and kilometers. So 15% improvement. So yeah, we've always done it. So your question is, how do we decide? How do we decide on our technology roadmap? It is a very good question because, well, as you know, Safran is not only an engine manufacturer. We make a large amount of the equipment, landing gears, wiring, cabin seats. So all these are products that are different. They all go on an aircraft, but they have different technologies, different constraints. So we do work on all of these. So we try to make them lighter because the weight is is really something we have to reduce on an aircraft. We also work on the propulsion of smaller vehicles. We will work on the electrification. We also work on enabling the wider use of SAF. So how do we establish the directions? So we have a Safran Group level research and technology roadmap, which is led by the Central Group R&T division, and which works with all of the companies. And the central division makes potential arbitrations. We also have processes for passing milestones in R&T. And we also have an external high-level scientific advisors council. Then there is arbitration, which is made according to a number of priorities, of course, according to the budget, of course. This is an important part. For example, I could give an example, which is, well, we know that the policies are going to change. We know that the standards are going to change, regulations. So in terms of environmental performances, we know that the standards are going to become more and more stringent. We have to get prepared for them, for that. So it's really important that we anticipate and we know how they are going to evolve. So, for example, being ready to comply with future standards is a must, is absolutely necessary, of course. That's why we need to follow the international policies, European policies, national policies. So there is also a strong link between the R&T roadmap and the world that is around us. We have to know the world that is around us, of course.
Is this awareness, right, of the world around us changing to be relevant in terms of research, in terms of prioritizing? And thank you for sharing the philosophy of how exactly you do this. Let's talk about the fuel that goes through this engine, right? You've talked to me about the actual manufacturing and the efficiency, but the fuel that goes through is important. And I'm specifically referring to sustainable aviation fuels. What are you doing to make engines that are 100% SAF compatible? Given that SAF is drop-in, does an engine manufacturer really need to do a lot? Is there a lot of work required? I'm wondering what it takes.
Yes, of course. We have to work on it because the fuel is burned in the combustion chamber of the engine. So the type of fuel that we are using, has a lot to do with the engine and with the aircraft systems also. First of all, if you allow me just to go back to the first question, well, the question
Sure.
about tries, I realized there is something I didn't say.
Yes, please.
And there will be a link. Because I said that engines are becoming bigger and bigger, but what I didn't say is why we are aiming at an open rotor. Well, it's simple to understand. It's because as the engine gets bigger, the casing and the nacelle around it get even bigger, and they become too heavy.
It's too heavy. Yep. The center
It's
of
too
gravity
heavy.
is impacted as well, as we saw with
Yeah.
the Max.
Yes. And it's too heavy and it creates a drag. So the idea is to suppress the casing and suppress the nacelle. Okay. The other thing I didn't say about RISE is, well, maybe I said it, but never mind. So it's a set of technology demonstrators, and this future engine will have a number of characteristics. And in particular, it will be fully compatible with 100% SAF. So SAF, as you know, what do we mean by 100% SAF? Today, aircraft are certified to operate with up to blending up to 50% SAF mixed with the traditional jet fuel. But in the future, if one day, we get to the point where we have 100% SAF, at least in some airports, at least from some delivery points, there will be places where there will be 100% SAF, then the aircraft and the engine will have to be able to operate with them with 100% SAF. So the link from the point of view of the aircraft and of the engine, what's happening? You have to realize, and I know you do, that jet fuel is great. Jet fuel has all the properties that we need, physical and chemical properties. But it's also great, and it has the properties that we need also because we have designed for the last century, even more than a century, we have designed aircraft and engines according to the properties of the kerosene. So that's, we don't realize that all the settings, all the progress we have made was always around a single type of fuel. So now we have to get prepared for working with fuels that may have but different physical and chemical properties from one point. And second, which is very new, is to change possibly, an aircraft can refuel with jet fuel on one airport and then goes to another airport and refuel with 100% SAF and then goes back and refuels with a 50% blend and so on. So this is something we have to, we need to ensure that our aircraft and engines are compatible. The fuel is not only something that we use for burning it. We don't only use it for an energy provider, but it goes in the systems. We use it for actuation. We use it for cooling. It gets, in contact with many parts and many systems of the engine and of the aircraft. And again, Safran does not only make engines, but we also make equipment that are linked to that. So the fuel goes everywhere. So we have really to ensure this compatibility. So it's not that difficult. We know we'll manage it. We know that we can do it. Dropping, non-dropping, it's a matter of technology development, but it's not the main challenge. The main challenge with SAF is not totally in our hands, is not much in the hands of the engine manufacturer, unfortunately, because it is the challenge of availability and costs. It's the challenge of the full value chain of the producers, of the airports, of the delivery, of the transportation, so of the banks, of the public, support, policy decisions. And that's really where the challenge is.
I think you led me very nicely to my next question, which is, what is Safran doing to help the scale up and the production of SAF, given it is not an easy road forward?
Well, first of all, we have, I have a very good answer to that. It's the Renewable Low Carbon Fuels European Alliance, RLCF Alliance, is an alliance which was created by the European Commission 3 years ago, I think, approximately. And the objective of this alliance is to create, first of all, to gather a lot of members and to create a set of successful projects in order to, I would say, kind of prime the pump of the supply and demand. So it starts from Europe, but it's open also to outside of Europe. And there are already 200 members. And the role of Safran here is that we have been instrumental in helping the European Commission to create this alliance. It's an alliance that deals with the hard to decarbonize sectors, which are aviation on one side and maritime on the other. So it has two chambers, aviation and maritime, and Safran chairs the aviation chamber.
And as heading this chamber, what is the result? What is the work that you're doing?
The objective is to get a set of projects. So we have a number of deliverable studies together to understand, what is needed. But really the objective is to deliver some successful projects for what I call successful projects is typically, projects to manufacture, to produce SAF, and also to help policy decisions. Because it is typically something that will work only from a collective point of view. We really need the collective coordination. We need, the technology, we need the policies, we need the producers to be on board, we need the financing. So to really help making the proper choices and the proper policy decisions. For example, one choice and one policy decision could be to choose the most relevant type of SAF according to a region, for example, or the most relevant type of SAF, or maybe making arbitrations between different types of transports. These kind of policy decisions that we cannot make at the level of the industry.
Thank you. As part of your work, are you able to share a bit about why Safran has invested in companies like Ineratech, which is developing e-fuels, for example?
Oh, well, it's directly in this, this is directly the result of this policy. See, we will have SAF. For having SAF, we need to have producers, and we need to foster the innovation. So Ineratech, it's a small company in Germany, which we are supporting, that makes e-fuels. And, they need to be supported. So we need to support a large number of projects to create this production.
Why Ineratech, or why e-fuels for that matter? Why not HEPA and other technologies that exist?
Well, of course, we need all of them. I'm not saying that we are counting only on e-fuels. We will need all the pathways, and more than the ones that already exist. But Ineratech was chosen because it was considered as, it had the, say, criteria, industrial technology criteria for us that make us believe it has a potential, a lot of potential.
Thank you. Well, thank you, I think, to Safran for supporting this as well. If we look beyond SAF, what about electric and hybrid propulsion systems, including, I believe we have partnerships with Aura, Aero, and Archer. What is the role of such technologies?
Yes. Well, it's not really beyond SAF. It's really parallel. We've been working on electrification of aircraft for a long time, for, I would say, more than 20 years. Of course, electrification of aircraft, you can work on the electrification of non-propulsive functions, which is something we have done, but we also work, which helps reducing the fuel burn. Then the projects you mentioned are really electric propulsion. So we have one of the Safran Group companies called Safran Electrical and Power, which is working on providing, well, they also make all the wiring on big aircraft and so on. So they are really our center of excellence for electrification, electric chain of the aircraft. So they have developed an engine, an electrical engine family called Engineus that can go on several types of aircraft. Basically, the objective here is, electrification will work on smaller vehicles. So it can work on first helicopters, or smaller aircraft, training aircraft, commuters. So it's, I would say, a proper solution and a very good solution for small type of aircraft.
Thank you for sharing that. This is very interesting how engineering expertise is going between companies as well. Hydrogen is also often touted as a potential future fuel, like an energy carrier. And you are doing hydrogen propulsion research, which is, I believe, in a joint venture with Airbus, the Ariane Group. What's the vision? What's the vision?
Yes. Yes. Yeah. Ariane Group. Ariane Group is our joint venture with Airbus. We make the propulsion of the Ariane rocket, and it is historically it was part of the Safran Group. So we have this know-how on using liquid hydrogen for the propulsion of rockets, space propulsion. Hydrogen for aircraft, it's a great fuel in the sense that if you burn hydrogen, you do not emit any CO2. So it's great for that. We know that there are many challenges. They have very often been listed. And the challenges are really technology challenges, but not only technology. Well, first of all, it's a real challenge to design a vehicle with a completely new type of fuel. And I'm not talking about SAF here. I'm talking about a fuel that has minus 235 degrees Celsius temperature, that doesn't have the same chemical and physical properties, not the same density. So the architecture of the aircraft must be very different. It must have a very large tank. It's also a fuel that has a lot of leaks, because when the hydrogen becomes not liquid anymore, it leaks. It also impacts the production, the distribution infrastructure, all sorts of concerns about security, safety, of course, safety, clearance zone for refueling, for example. It raises questions about, how do you harmonize between airports that will have hydrogens, airports that will not have hydrogens. So it's this whole thing about distribution, actually, dealing with the cold. The other requirement, absolute requirement, is that the hydrogen must be produced without emitting CO2, which is also, we have to work on that. There is a lot of research to be done on that. And above all, I repeat, safety, we cannot compromise on safety. So this will have to be dealt with. So, we know that in the history of technology, and even in my own career, which was much, much shorter, I have seen solutions that were, left out at some point, or people did not believe in them, and then they reappeared, and then they became a success because we got the right technology bricks, for example. So we need to continue working on research on hydrogen. We consider it is long-term research at this point.
Given it is long-term, I think a majority of the efficiencies will be coming from newer engine designs, more efficient engine designs, and even sustainable aviation fuels rather than hydrogen or electric for a majority of aviation, right?
Yes, well, the challenge, we have to work on all aspects. They are complementary, but indeed, if you speak about liquid fuel engines, including hydrogen, no matter which kind of fuel we use, we will have to burn less. We will have to use less fuel for the same service, for carrying the same number of passengers on the same distance. So, whether it's kerosene, whether it's SAF, whether it's hydrogen, we need to use less of them. So the energy efficiency is really something we are sure that it is going to deliver a result.
Indeed. Thank you. And once again, thank you for diving deep into each of the answers. Let's talk about the eco-design process. I believe it is based on ISO standards. How is this changing the way in which you develop products? And have you seen any benefits?
I would say it's a bit early to say if we have seen yet any benefits, because we're still on the learning curve on this. So we are yes, we are implementing an eco-design process. One of the challenges in a group like Safran is also to integrate and to integrate it and to harmonize it throughout the companies. As I said earlier, we make products that are different. So, to harmonize the methods throughout the companies that make different products. We have at this point design processes on the repair, so to ensure that a product can be repaired, disassembled, so that's one first step that we're making.
Thank you for sharing that as well. Valerie, I have to ask you, one of the big tussles the industry faces is between balancing growth and the need to reduce emissions. The travel industry, the aviation industry is growing. What are the trade-offs, if any, that you foresee in balancing growth versus sustainability?
Well, first of all, I want to say that as an engine and equipment manufacturer, we have no power on growth. We do not, I would say, what creates the growth of, you're talking about the growth of traffic, the traffic air traffic growth, of course. So we do not have the power to, we do not have I would say a button or a knob to act on the world traffic growth. And I insist on the term world traffic growth because, as you know, aviation is global by nature. And so what makes the growth is really the demand in all the countries and all the regions of the world. So today, what directly influences the traffic growth is the world economy and the GDP growth of countries. This is really the first order of magnitude influencer on the traffic growth. Probably public policies can also influence. And I suppose this is a bit what's behind your question. But we observe that it is in a second order of magnitude at this stage. I believe personally that public policies are needed in general. We always need public policies, and in particular in front of the climate challenge. But I believe that traffic moderation or traffic limitation or less growth will come from increasing the costs of flying. And it is very likely that flying will cost more, and in particular with the use of SAF. Currently, we are updating the European roadmap called Destination 2050, where we are modeling the various parameters, and we observe that the cost of SAF is probably what will have the most impact on traffic limitation. So I think that that's probably a way to do, but we have no other way. Our lever is really to provide more efficient vehicles, no matter, independently of what the traffic will be. Because independently, we need to have more efficient vehicles.
So are you then suggesting that as the cost of sustainable flying is passed on to consumers, demand will automatically decrease?
Yeah, it is likely. It is not very fair because well, we used to say that, in the past, only wealthy people could travel by plane. Today, it's not the case anymore. So it would not be necessarily economically very fair, but it is likely. But it is only one lever, really, only one lever. And it is in the hands of the public policies. They have to make the right decisions. Our role is to provide them with our research, our technology, and to contribute to whatever roadmap and decarbonization trajectory will happen. If I can simply add, I said the word world is very important, because the
Yes.
difficulty there is that if we speak about public policies, we need public policies at the global level. Public policies, there are public policies going on at the European level, which is a very good start. And in particular, with the Green Deal, the European Union has set up a package of legislative acts, such as Refuel EU Aviation for promoting SAF, the EU ETS, and so on. Yes, at the level of the countries, it happens. It happens also in the States, but it is necessarily different according to the regions of the world, while the CO2, the emitted CO2 is impacting in the same way everyone.
Right, exactly. No, thank you for sharing the global perspective as well. And I do believe, yes, the European Union is taking lead and setting an example for many others to follow. What about scope 3 emissions, particularly those related to product use that represent a large part of Safran's actual carbon footprint? Can you explain your approach to reducing these emissions and what are the challenges involved?
Yeah. Well, scope 3 emissions for us is definitely, well, it's the emissions that come out of our engines when the products are after we have sold them. So our products are operated, used, and so our scope 3 is really the emissions that come from the engines in operations. So that's also why we work so much on it. But as I said, we work on the energy efficiency. We have no real, we respond to a demand. That's how companies work. So our way to reduce scope 3 is to commit to a significant reduction through the levers I have mentioned. So through the technology, the energy efficiency, and through the use of SAF.
Got it. Thank you again for sharing. What about the rebound effect? You know, when we were preparing for the interview, we sort of discussed the rebound effect, where when you
Yes.
improve energy efficiency, cost decrease, demand increases. How does that play into here?
Yes, yes, that it is an interesting point, because it is the rebound effect is something that I read a lot. A lot of people say it is not. It is useless to improve the energy efficiency of the aircraft, because there will be a rebound effect. Because the more you reduce the fuel consumption, the less costly it becomes. Therefore, you increase the traffic, you reduce the price ticket, and then you increase the traffic. And we can recognize that in the past, this is what happened. We have made tremendous progress in reducing the price of tickets. And then it has created this increased demand. So it has kind of offset the progress we made. Now we are, as I was saying, we are at a time where flying will not become cheaper, because our levers are very costly. It is very costly to develop the technologies. The airlines will have to buy those aircraft. They will have to renew their fleet. And airlines will have to buy the SAF, which is very costly. So airlines will have a lot on their plate and a lot to pay. Currently, I do not see how there could be a rebound effect in these conditions.
Agreed. Flying is about to get a bit more expensive for many people around the world. You are doing things like the annual supplier day. So where you're rewarding people or suppliers for their decarbonizing innovations. Can you tell us a bit more about this? It's very interesting.
Yes, that's part of the engagement program, indeed. So we engage those 400 main suppliers. We ask them to, have a decarbonization action plan. We ask them for a maturity questionnaire. So we also train them. We provide them with training. And there is an annual supplier day with an award for the 3 suppliers that had the best innovations for decarbonizing.
Thank you. Thank you for sharing. This has been a fantastic interview, and I've learned so much. I have to go back to our first question where you mentioned you've been at Safran for 36 years.
Yes.
As an engineer in a generally male dominated field, what challenges have you faced? Is gender balance a real thing, even in your part of work? What advice would you give to young women considering
Yes.
aerospace engineering or even sustainability careers?
Yes, thank you for the question. It's important. And I also know that you made a point of interviewing more women in your podcast. And I think it's extremely important that you do that because young women need to listen to other women and to
Indeed, we
hear.
have always maintained gender parity, and I'm very proud to say that till date we have maintained gender parities, at least 50% or more women.
Good, good. I would say that I entered this male dominated field more than 40 years ago because I decided to study engineering in 1981. So I was 18. And then 2 years later, I picked mechanical engineering and then I specialized in aerospace engineering. And each time I made those choices, I was really going straight against the stereotypes and the tradition. I cannot tell you all the stupid things that I heard at that time. I would say that the most difficult was really to start, but it really required determination. It really required to be very sure and some courage. And at that time, there was not much help. So I would like to say that the most difficult in my 40 years journey was really the first years. Then I would like also to mention I took some kind of a breath of fresh air when I studied in the United States. So I spent 3 years of my study time abroad. So 6 months in the Netherlands and then 2.5 years in the States. And I really enjoyed very much the way women were treated in the States compared to France. It was really a progress. I think they were ahead of us. The US was ahead of Europe on that respect. And when I went back to France, I had some kind of a culture shock. And I didn't like very much the way women were treated on the workplace. So this was the second difficult time of my journey. But I really have to say that it has improved a lot over time. It has improved because, first of all, myself, I have gained experience and I was much more self-assured. And I realized that I enjoyed very much my job. And also the last 15 years have showed, a time of very big cultural change. And I would like to say that finally, so the mindsets have changed, the communication, the awareness, but for me, the most effective is the law. If you have a law that forces companies to hire women, to treat them the same way, to pay them the same way, that's a real game changer. And that has made a strong difference.
Very
Yeah.
inspiring. I almost feel we can record a completely separate interview on only your journey in the
Yeah, it's
area.
a subject.
Yeah,
It's a subject that very important for me. Yes.
yeah, exactly. So, final part of this interview is where we get to know you a bit personally, and it will be very quick. So, we'll ask you simple questions like, "What's your favorite book?"
So I pick Le Comte de Monte Cristo by Alexandre Dumas, which is a book I read 3 times in my life, and the first time I was
Wow,
13 years old.
wow, amazing. Favorite airline?
I'm sorry, I'm going to be very French-centered in my answer. I pick Air France for a reason, which is I do not fly very often. I fly about twice a year, two or three times a year. I have not flown enough to really make a comparison, and the airline I have flown the most was Air France. And I've been satisfied with it.
Okay, fair enough. Favorite city? Are we still saying in France?
It's well, my favorite city is my birth and home place, and it's Paris.
Amazing, amazing. Favorite movie?
My favorite movie is a French movie. It's called Peau d'âne. So it's taken from it means donkey skin. So taken from a very old fairy tale. It's the fairy tale that was never made into a Walt Disney movie, and unlike many others, and it's a very beautiful French classic.
Glad to hear. I'm going to definitely check these out. What is something you do in your free time?
My free time?
Yeah.
First of all, I'm really happy I can answer this question, because for many years I was unable to answer this question because I said I simply have no free time. So now I'm done with raising children. So I have free time now. What I do, well, I visit a lot museums and art exhibits. I love museums. I love paintings. Last year, I took art history courses at the École du Louvre in Paris for 1 year, one school year. I write. I like working with my hands, sewing, fixing things, gardening, of course, family and friends.
You like to use your hands, I see.
Yes,
Excellent.
absolutely.
Yeah.
Some people tell you for a good balance, I need to do sports. I cannot only work with my brain. And for my balance, I need to work with my hands also. I don't do sports, but I love making things, fixing things.
Yeah.
Yes, and
Very nice. What is something you'd like to learn?
Well, I would like to learn how to work with my hands even more.
Okay.
Anything that is useful for renovating an old country house, such as carpentry or masonry.
Wow. Okay. Very interesting. Final question, Valerie, for you. What is the best advice you've received?
The best advice I received was from my godmother. When she was 90 years old, she's dead now, but she was 90 years old. She said that her biggest mistake in life was to think that she was old when she was 50. And I always remembered that at that time when she said that, I was, I don't know, maybe 40. And today I am much older than 50.
Wow.
And I do not think I am old.
Wow. Fantastic. You make me feel young, and I'm glad to see the young spirit alive and kicking within you as well. Valerie, it was a pleasure speaking. Thank you so much.
It was a pleasure speaking to you as well.
Thank you for listening to this episode of Sustainability in the Air. Aviation is one of the hardest to decarbonize industries, yet there are multiple paths to get to net zero. Awareness is key to a green future. So please give us your support to help our sustainable aviation insights reach a wider audience. You can do this by sharing this episode on your network, on LinkedIn, Twitter, or even WhatsApp. Or perhaps you might consider leaving a review on Apple Podcasts, Spotify, or wherever you listen to this episode. You can start a conversation with us by writing to us at podcast@simplifying, that's simply with an i.com. And for more content on sustainable aviation, please visit our website green.simplifying.com and join the movement. Sustainability in the Air is an original podcast by Simplifying. The show is produced by Juraj Toth in Slovakia. Dirk Singer is our Director of Sustainability, who leads research for each interviewee out of Greenwich, UK. Shubhadeep Pau is our Supervising Editor based out of Mumbai and Singapore. The articles are written by Ayushi Badola in Dehradun in India and Meera Hull in Montreal, Quebec. Creative design is led by Ligia Esteve in Montreal. Baiba Drimen is the project director for the show based out of Valencia, Spain. Special thanks to Wendy Sim in Singapore. And I'm Shashank Nigam, the CEO of Simplifying and your host. Please feel free to connect with me on LinkedIn.